If you've heard of big data, you've definitely heard of Hadoop. But what most people picture is just the engine. Today, we're going to crack open the entire toolbox and explore the full Hadoop ecosystem. Hey everyone, and welcome. Whether you're deep into a computer science degree or just really curious about data infrastructure, you are in exactly the right place. We're about to unpack one of the most important toolkits in the entire big data world. So you've probably heard of Hadoop's core components, HDFS for storage and MapReduce for processing. But here's the thing. Thinking that's all there is to Hadoop is like thinking a power drill is the entire workshop. The reality is, Hadoop is a complete toolbox for big data, and we're going to see exactly what's inside. Here's our game plan for touring this workshop. We'll start with Yarn, who's basically the manager of the whole operation. Then we'll check out a very specialized storage tool, HBase. After that, we'll see how tools like Hive and Pig let you actually work with the data. And finally, how Zookeeper keeps the whole thing from falling into chaos. Then we'll put it all together.
All right, first up, Yarn. If our Hadoop cluster is a busy workshop, Yarn is the workshop manager, making sure every single project gets the resources it needs without stepping on anyone else's toes. So let's think about the core problem here. It's awesome to have the massive power of HDFS and MapReduce, right? But in the real world, you're never just running one single job. You've got multiple applications, different users, all fighting for the same resources on your cluster. How do you prevent total gridlock and keep everything running smoothly? And that is exactly what Yarn was built to solve. It stands for Yet Another Resource Negotiator, which is a bit of a funny name, but its job is absolutely critical. You can think of it as the operating system for your Hadoop cluster. It has to do two huge things at once: manage all the resources across the entire cluster, and at the same time, manage the very specific needs of every single job. And the way Yarn pulls this off is pretty brilliant. Instead of having one single overwhelmed process trying to do everything, it delegates. The resource manager is like the CEO. It has the big picture view of the whole cluster. But for every single application you launch, Yarn creates a temporary application manager that negotiates resources just for that one app. And on every machine, you have a node manager agent that's constantly reporting back on local resource use. It's this smart division of labor that lets Hadoop run all sorts of different jobs at the same time without collapsing. Okay, so our workshop is now well managed. Let's talk about the different kinds of storage you might find inside. This brings us to a really important tool called HBase. HDFS is fantastic for its main job. You write enormous files once, and then you read them over and over again for analysis. But what if you need something more interactive? What if you need to quickly look up a single customer record or update one specific value in a massive dataset right now, in real time? HDFS just isn't designed for that kind of surgical strike. To solve that problem, the ecosystem gives us HBase. It's a non-relational, columnar database that's built to sit right on top of HDFS. Now, it was inspired by Google's legendary big table, and that should tell you everything you need to know about its scale. We're talking tables with billions of rows and millions of columns. It's designed to give you that super fast, random read and write access that the core file system just doesn't have. And this analogy really nails the difference. If HDFS is the giant Costco-sized warehouse where you store massive pallets of data, then HBase is the perfectly organized set of filing cabinets or quick access drawers right there in the warehouse. You don't search the entire warehouse to find one specific screw. You go to the drawer that's labeled screws. That's what HBase does for your big data. Okay, so we can store our data in a couple of different powerful ways, but how do we actually work with it? How do we ask it questions? Let's check out the workbenches of our workshop, Hive and Pig. Let's be honest, MapReduce is incredibly powerful, but writing raw MapReduce jobs in Java is complex. It's slow, and it was a huge roadblock for data analysts and data scientists who just wanted to ask questions of the data without needing a PhD in Java programming. So the ecosystem gave us two fantastic but different workbenches. On one side, you've got Hive. Hive gives you a language called HiveQL, and it looks almost identical to SQL. So if you come from a database background, you can start querying massive data sets in Hadoop almost immediately. It's an absolute game changer for data analysts. On the other side, you've got Pig, which uses a scripting language called Pig Latin. It's more procedural, and it's perfect for programmers who need to build complex data transformation pipelines and test them out quickly. So two different tools for two different kinds of users. So we've got our manager, our storage, and our workbenches. But with all these different parts running across potentially hundreds of machines, what keeps the whole system from descending into absolute chaos? Well, that is the job of the coordinator, Zookeeper.
I mean, really think about that for a second. You have all these services spread across a massive cluster of machines. How do you make sure everyone's using the right configuration? How do you make sure tasks happen in the right order? How do you send messages between them and know for sure they were delivered? It is a monumental coordination challenge. And the source material puts it perfectly right here. Zookeeper is the central nervous system. It's the conductor of the orchestra, coordinating all the different distributed pieces.
It does this through 3 core jobs. First, process synchronization. It's like a traffic cop for all the tasks, making sure they start and stop in the right order. Second, configuration management. It acts as the single source of truth for settings, so every node in the cluster is on the same page. And third, it provides reliable messaging, guaranteeing that critical communications aren't lost, even if machines fail. Zookeeper is the unsung hero that makes the entire system resilient.
So let's step back for a moment and look at the whole picture. Let's see our complete toolbox all assembled. And here it is. You start with that powerful core engine, HDFS and MapReduce. Then you add Yarn as the workshop manager, HBase for that lightning-fast data access, Hive and Pig as your user-friendly workbenches, and Zookeeper as the coordinator making sure it all runs like a well-oiled machine. Together, all these pieces transform Hadoop from just an engine into a complete end-to-end platform for pretty much any big data challenge you can throw at it. So that's the foundation. But what's the next chapter in this story? Now that you have this incredible power to store, manage, and process massive data sets, the real question becomes, how do you integrate this with all your other data sources? And how do you move beyond just processing data to performing truly advanced analytics? That's where this journey heads next.